Continuing with our quadratic modeling, in example 2, we'd like to build a fence to enclose a rectangular garden, and we're going to separate the enclosure into 2 sections using a fence down the middle. We'll make our fence parallel to the short sides of the rectangle. Before I read any more, I have a picture in my head right now. I'd like to draw that because I need to kind of get down what's going on here. So I've got this rectangular garden, and then I want to put a fence down the middle parallel to the short sides. That'll make 2 sections. Okay. Just gets me thinking about what's going on. All right, we have 750 feet of fencing to use, and I want to work by hand this time to answer these questions. And the first thing I want is a function a of x that represents the area A of the, whoops, that should actually be of the garden, in terms of the length of the short side, x. So the short side is x. That means this is x, and this is x. All right, we know that in general, area is length times width for a rectangle. And our width is x, but we're going to need some expression for the length in order to be able to come up with the function for the area. So let's go ahead, and for right now, let's just call that length y. Top and bottom. I know that altogether I only have 750 feet of fencing to use. So if I build this, I'm going to have 3 sides of length x plus 2 sides of length y. And if I use all my fencing, that's going to be my 750 feet altogether. I'd like an expression for the length y, so let's solve that equation for y. I'm going to subtract the 3x to move it over to the right-hand side. And then I'm going to divide by the 2. So let's see, 750 divided by 2 is 375, minus 3 halves, I'm going to call that 1.5x. So my area function, length times width, is the length, which we just found out was 375 minus 1.5x, times the width, which is just x. I can multiply that out, 375x minus 1.5x squared. And I could now call that a of x, since the input variable is just x. All right, in part B, we'd like to find the dimensions of the rectangle that give a total enclosed area of at least 15,000 square feet. So I need the area to be at least greater than or equal to 15,000. If I put in my area function, it's going to look like that. All right, this is another one of those where nice problem that we can have the technology solution so that I don't have to start getting related equations and everything. Let's just put both sides of the inequality in the calculator. And on the window, oh, let's see, I've got 750 feet of fence, so I've got a lot of, my x value can be fairly large. Let's go, let's go 0 to 200 anyway, with a scale of 10. And my area's got to be at least 15,000, so I'm going to go fairly large on that. Let's go 0 to 50,000, see what happens. All right, looks like I'm kind of running out of space over here, so maybe I need to let my x values be a little bit bigger. Let's go with an x max of maybe 400 instead. There we go. All right, I wanted the quadratic, the parabola, to be bigger than 15,000. So that would be the part in here where the parabola is above the 15,000 square foot line. And again, if I just kind of sketch what I see, the part that satisfies my inequality would be this part right here. So I need x values. The intersection points from the calculator, I'll get the smaller one first. Enter, enter, enter. That's at an x value of 50. 15,000 is the y, just as it should be. And again, that one's at 200. So my rectangle width has to be between 50 and 200, or the width of my garden. Between 50 feet and 200 feet. Will result in an area of at least 15,000 square feet. All right, finally I want the dimensions that enclose the maximum possible area. So if I once again just kind of steal the picture from here, the maximum will once again be the vertex. We see that over and over, right? And let's see, I'm done with the 15,000, so I'll clear that out of there. And I'll use my calculator to get that maximum. Looks like 125. Although I don't think I asked, if I want to put it down here, we can actually talk about it. It's 23,437.5 is the actual maximum area that I'll get. All right. That's the x, or width of the rectangle. But since I've only got one rectangle to talk about, it says dimensions. Let's get the length too. If you remember all the way up here, my length, y, was 375 minus 1.5x. So plugging in the 125 gives me a length of 187.5 feet. So a garden that is 125 feet wide and 187.5 feet long will have maximum area. And although didn't ask, I can even tell them that area is going to be 23,437.5 square feet.